morning. Great presentations, great speakers already, and I'd kind of like to start mine off by saying I'm lucky and I feel proud to be the third speaker in a row, born and raised in New Mexico. So before I say where I'm from and my educational background, I want you guys, if you can, to take a quick step out of your bodies and feel if you feel any animosity when I say this, okay? When I say animosity, like a rivalry, like something that's like, you don't like what I'm saying. I'm born and raised in Santa Fe. I went to Santa Fe High School, and then I went to New Mexico State University for mechanical engineering, right? Thank you. So I say that because I could feel when Doug was talking, he's like, Albuquerque, Cibola, and I'm like, oh, rivals. And that's not the right time for that, right? We're here talking about Innovate New Mexico. We as New Mexicans, and I'd say Space Valley, all the way from Colorado down through New Mexico, down into El Paso, Texas. We are trying to build a space economy. And so anybody who's from New build a future economy. And so now that kind of leads me into my presentation to talk about what we NASA have to offer as far as opportunities for small business. I do want to, yes, it does. All right, so what I wanted to talk about is a lot of people may not know what Artemis is. There are a lot of opportunities within the Artemis program for small businesses to enter right now. And even as we extend Artemis into future missions, there's a lot of future opportunities for way down the road for Artemis missions, and really the precursor to all of that is the Commercial Lunar Payload Services, or CLPS. And then for those who maybe don't know about what we do at White Sands, I have a quick overview. My boss, our site director, Jason Noble, he presented last year about what WSTF's capabilities were. If you hear me say WSTF, that's our acronym. We just say it as a word. And then how to do contracting business opportunities with us. So Artemis, it is a foundation for deep space. It includes these architecture systems, Space Launch System, and I'm gonna kind of come back to talk about who are the prime contractors on each of these. The Orion spacecraft, human landing systems, surface operations, gateway, exploration ground systems, space communication navigation, service mobility, spacesuits, and surface infrastructure. If you followed NASA, you know we've already launched Artemis 1. That was last November 2022. And the whole rocket stack is really primed by Boeing. The boosters themselves are Northrop Grumman, and the engines that push it are made by Aerojet. These are all companies, all for making their systems better. The Orion spacecraft, the capsule itself, primed by Lockheed Martin. The push system, the service module, is actually made by the European Space Agency and Airbus. Human landing systems, we are just getting to that point, as well as surface operations. We haven't even started letting the contracts for those for human space operations, but that's coming. Gateway is the next space station we're about to start building, and it's behind the moon. So you might have heard the current International Space Station, we're planning on de-orbiting soon. The next thing, which is our jump point to either the moon or to Mars, is going to be this Gateway space station. So that's a lot of work that's coming. Let me just kind of quickly go through this. Surface mobility, NASA's in the process of building a unpressurized rover, but we're working with the Japanese Space Agency, and they're competing power systems with Toyota and Honda for building the power system for a pressurized lunar rover. So if you've ever seen the movie The Martian, where Mark Watney's driving on Mars in this pressurized rover, we are building that. We're in the process of designing and building that for the moon, making lunar human operations a reality. Spacesuits, that's already being outsourced to another company, Maxar, for lunar suits. But again, there's a lot of innovation, a lot of new technologies that could be developed to improve the suits that we use in extraterrestrial environments. And then surface infrastructure, I'm going to get a little bit more into that. A little more on Artemis. I already said we launched Artemis 1 in 2022. That's complete. We've now selected a crew for Artemis 2. Artemis 1 was an unmanned mission around the moon. The Orion vehicle flew the farthest away from Earth than any human-rated spacecraft is. Orbit and return to Earth, and that's slated for late 2025. Then we get into Artemis 3, which is the actual landing of people on the moon. No date for that's quite selected yet, as you can imagine. And then Artemis 4 is where we start assembling that gateway space station out behind the moon. Artemis 5, we start putting unpressurized rovers and having people develop a longer-term presence on the moon. Artemis 6 is that pressurized rover. And then beyond, we are establishing a human colony, a human permanent element on the moon for learning how to do deep space, hard environment living situations, which is going to give us training and practice for going deeper into space, going to Mars, and going beyond. There are a lot of technology objectives with Artemis. And as you can imagine, it's really expensive to take things from Earth up into space. And the farther out you go, the more propellant you need. So things become more expensive. So the less we have to take with us, the lower cost it is for us, plus the easier because we don't need as much propellant to send it. So if we can learn how to use the materials of the destination that we're going to for building habitats, for using or water or air or fuel, we are making it cheaper for us. Plus, this is also kind of where it ties into some of the discussions that we had this morning of clean energy, lower recycling use, environmental. These are things that we're going to have to develop to go to these harder destinations, which are tech transfer things that can come back to Earth for being able to there's no atmosphere, there's no wind to round out the dust. So they're actually sharp little silica things that can cut our suits. So those are extreme environments that we need to learn how to live in. Putting people into those extreme environments, giving them enough air to breathe and water and all the things that make life possible in those foreign environments, those are all things that we're going to have to conquer to work on. Excavation and construction. We don't even know how to drill into the moon yet. We don't know how to drill into Mars other than little core samples. But if we're going to make use of resources in those areas, those are technologies that we're going to have to learn how to do, and we can start practicing here on Earth. So all of that kind of stuff is things that opportunities for small business to start helping with those farther destinations. This one you might have seen on the news recently, ODI or Odyssey, right? It's the Intuitive Machines commercial lunar payload where they landed on the moon. They did have a slight velocity as they were landing, and it did tip over, but you see the picture on the top left of Odysseus as it was descending to the lunar surface. This is important because this is actually making things cheaper for NASA. If NASA were to try to build a payload, we'd have all kinds of risk protocol and cost and testing for making our payload successful. The CLIPS program is really trying to decrease life cycle time, decrease costs, and really kind of help accelerate and develop a commercial space industry. Rather than the government doing it, we're trying to incentivize commercial companies to do different landers. Open to partnerships, open to companies reaching out to them with ideas. These are those 14 companies, and there's more to come, right? There's more of these CLIPS opportunities in the future, so if you're interested or you'd like some more information, please either see me or Ariana Guerrero or Walt. Walt has a table right over here, but all from the NASA booths. And we'll be happy to talk to you more about those commercial opportunities or partnering opportunities. Now, really quick, again, back to New Mexico. Where we are, White Sands Test Facility, we're on the White Sands Missile Range. We are a tenant on the missile range. If you look at the little blue WSTF dot, that's how much of this space we occupy. Very close to Spaceport America. And right there on the I-25, I-10 corridor. So we do share the airspace with WSMR, so we don't have planes overhead. We do specialize in hazardous testing. I'd say we have 7 core capabilities at White Sands Test Facility, where we specialize in rocket propulsion testing, primarily hypergalls, and definitely in space. So we have large altitude test stands that we can fire rocket engines and simulate space conditions as those rockets are firing. If we're going into space, you got to take oxygen. Astronauts need oxygen, air to breathe. And Apollo 1, our site really took off because of the Apollo 1 fire, where 3 astronauts died because it was a fully pressurized 100% oxygen capsule. A lot of testing and a lot of expertise has been built at White Sands to understand oxygen flammability. And we teach people how to handle oxygen safely. We teach people how to analyze their systems for material compatibility, for flammability, and we can perform testing for fluids. Kind of captures everything else that is used in aerospace. Hydrogen, hypergalls, ammonia, hydraulic fluids. All of these have varying toxicity or corrosivity, material concerns, and so we do testing on materials, components, the fluids themselves, and how it will behave in your system long-term in space. This one's kind of cool, hypervelocity. We simulate space junk. We simulate micrometeoroids, and we have guns that we can shoot single projectiles up to 8.5 kilometers per second. Think about how fast that is. It's faster than orbital velocity. Orbital velocity is about 7.5 kilometers per second or 15,000 miles an hour. So we're shooting projectiles faster than that to test spacecraft shielding, test other materials, cables, solar arrays, windows. Recently, we even shot one of the beryllium mirrors from the James Webb Space Telescope because it did suffer an MOD impact behind the moon. Light acceptance and standard test. If you're going to send anything into space in a habitable environment, you have to pay attention to toxicity, off-gassing, and flammability of those materials. You don't want to fire in your space capsule. You don't want to send something up that's toxic and it's going to off-gas and kill your astronauts. And really, you don't even want a nuisance odor to get up there. Imagine taking a Sharpie where you can't roll down the windows and vent out the bad air, so you make sure you don't send something up that smells bad to begin with. Composite overwrap pressure vessels. A lot of companies are going to higher pressures and using lighter weight tanks. And one of the tank designs is a composite overwrap pressure vessel. Those are very susceptible to inspection protocol or something was missed. And so we not only perform the testing, but we teach people how to inspect their COPVs for damage for use in service. And then spaceflight component services is a catch-all because we take old rocket engines and we refurbish them. If you watch any of the Discovery Channel or the Learning Channel shows, they take old cars and rebuild them and fix them. We do that for rocket engines. So those are also available for not only government contractors, but some companies that are supporting government contracts because it is government hardware. Partnering and contracting opportunities. NASA is part of the federal government, and so if you want to do business with us, we have to enter into a Space Act agreement. It's something that we, the government, can't compete with private industry, but if we have unique assets, unique capabilities, you're more than welcome to partner with us. Those kind of tend to take a while. They can take 6 to 8 months to a year to set up an umbrella. And then the way we do work is through annexes under that Space Act agreement. We, White Sands Test Facility, have already entered into umbrella agreements with New Space Nexus, as well as in the process and almost signed off with the Spaceport of America. So I mention those because in this group, in this room, if there's companies who want to be able to access our unique capabilities for testing for your project, you can contact either New Space Nexus or Spaceport America, because we already have an existing umbrella agreement. We, NASA, can work with those companies to develop the annex to do your testing for you. So have 2 prime contracts, one for our test evaluation services called Test 3, and that contractor is Sierra Lobo. They have a sub named Wolf Creek. And then on our environmental side, we have a separate contract, which is prime with Navarro. There's something else there, Navarro Industries, I think. Anyway, it's Navarro, and for all opportunities that NASA sends out for either RFPs or looking to do business, you guys are probably aware of this, but look at sam.gov or the nasa.gov procurement site. Let's see next. Yep. Well, all right. Well, I guess with that, that was my last slide. And so I'm happy to take any questions if anybody has any. Yes, sir. Sorry.
Had to do with the country sent out a colony because they wanted to trade something. So what do you anticipate we're going to be bringing back from the moon that we want?
So what are we going to be bringing back from the moon? That's kind of like the great question that's always been asked of NASA. Why do we send people to these places? We can already do robotic prospecting missions. Why should we spend the money on people going, right? I'm twisting your question slightly, because what is it that we're going to bring back? And I think those 2 questions are kind of related, in that what we are going to bring back are the new technologies that are developed which could spin off into technologies here. But it's also establishing the stepping stone for us, taking it farther into the solar system, farther to Mars. Because right now, the communication delay between Earth and the moon is just over 1.5 seconds. It's traveling the speed of light, it takes about 1.5 seconds to get to the moon. Traveling the speed of light, it takes about 20 minutes to get to Mars. So if we have astronauts landing on Mars and they want to call Houston, we have a problem, it's going to take 20 minutes for that signal to get to us. And then by the time we work on it and respond, it's going to be another 20 minutes back. Imagine waiting 40 minutes to hear an answer. So part of what we're going to learn how to do in these Gateway and lunar surface missions is we're going to learn how to better do human autonomous operations. So where people can't call back and ask for help with the body of knowledge. Maybe that's where AI kind of also starts to get involved, because you have this, all these science fiction movies start popping into mind, right? Like Odyssey 2000, where you have HAL, who's the supercomputer that knows everything. But, sorry, I got distracted on a tangent there. Learning how to do these autonomous human operations by inserting a communication delay helps us get better for Mars. And then I don't know necessarily that we're planning on bringing something back from the moon other than knowledge, how to do prospecting and utilizing resources of the place that we go to. There's probably one that's more pertinent to your question, and it's a mission that we just sent out this last year called Psyche. It's this huge body where we have not a prospector, but a probe that's going there to actually measure what is on that body, because that could then establish a mining colony. And then this Artemis work of learning how to work deep in space translates directly to sending people for prospecting out in those areas for mining and bringing materials back. Sorry, long-winded answer, but hopefully that. Out of time. Okay. Yeah. Thank you very much.